In this lesson, I will introduce one of the more important elements of the Explorer, that being dynamic displays. More than 15 years ago, as I was beginning my PhD research into seismic visualization, I realized that because of the three-dimensional nature of what I then called SeisScape displays, I could combine different attributes together in unique ways. I gave a presentation on the subject at the 2004 SEG convention. It was called Combined Attribute Displays, and I've included PDFs of both the abstract and the talk in this lesson. It's not required, but to get a sense of where dynamic displays come from, you might want to pause the video and review both now. Dynamic displays are the direct descendants of that talk, and they are important for two reasons. First, because they let you morph and difference between processed versions, they are useful for evaluating the effects of various processing steps and post-migration filters. Second, they are useful for any type of interpretation that uses multiple attributes. One of the drawbacks to seismic attributes is that once you start to use them, you lose the very familiar context of the seismic amplitudes. Dynamic displays let you interpret attributes while retaining the original seismic context. You will see what I mean by this later in the video. To begin, I will use the offshore Netherlands F3 block as my example dataset. So, if you're following along with me, pause the video here and open it. To get started, I will open an inline display. You might want to do that yourself. I will say at the outset that this lesson is not a comprehensive examination of dynamic displays. Dynamic displays are a major feature of the Explorer, and understanding all the various settings, most of which you find on the foreground and background properties tabs, is a chapter in itself. All I will do here is give you an overview of what dynamic displays are and how and why you might use them. As for the specifics of how to set up each individual attribute, we will get into that as we move through the course. The basic functionality for dynamic displays is found on this tab, which, by pure coincidence, is called Dynamics. Dynamic displays work by combining two surfaces together in different ways. The surfaces can either be different imported versions, or they can be one of our instantaneous attributes that are calculated on the fly. What I will do now is go through the various types of displays that you can create and give you a sense of how to use them and what you might use them for. Perhaps the Explorer's most important technique is the ability to morph between two different surfaces. If you are morphing between two different versions of the seismic, then you would use this format, the version morph. Here I will morph between the original seismic and the dip-steered median filtered version. As you can see, the morphing gives you a good idea of the effect of the filter, and it is perhaps our most useful technique for evaluating various processing steps. The companion dynamic display to morphing is differencing. Differencing, rather than morphing between two surfaces, progressively subtracts one from the other. This display gives you a clear picture of the information removed by a filter. This is our other display that is extremely useful for processing, and it's used all the time. The rollover display is used for both evaluating processing and for comparing different attributes. To get the full effect, I will switch to a wiggle trace display and show you how it works, although it also works for every other type of display. It dates to the days when we used to compare different processing versions by rolling a paper copy of one back and forth over the other. To use the rollover display, after you have set it up on the Dynamics tab, go back to the Home tab and select the Select Objects mode. Then, point somewhere in the display, press and hold down the left mouse button, and then move the mouse left and right. As you can see, this gives you the appearance of rolling one version over the other, and although I do not use it a lot myself, other people seem to. Version morphs, differencing, and rollover displays are the techniques that we use to compare different seismic versions that have similar properties. We will turn our attention now to working with attributes and versions that have different properties. The technique that we use for those are attribute morph, multi-attribute, multi-surface, and again, the rollover display. This is where the concept of restoring context to attributes comes in. To illustrate, I will switch to displaying instantaneous frequency, an attribute that is often used in stratigraphic interpretation and when looking for gas shadows. Looking at this display, there is a wealth of information in it, but how do you make sense of it? As with most seismic attributes, it takes us into unfamiliar territory, and without the original seismic to relate it back to, it's very hard to make sense of what we are looking at. But now, let us select the attribute morph display and configure the display to morph between the original seismic and the instantaneous frequency. Now, as we morph back and forth between the two attributes, you get a much better picture of how the instantaneous frequency relates to its parent seismic. Here, I will morph between the cosine phase, another useful attribute, and the same instantaneous frequency. As you can see, the morphing makes both attributes far more useful and informative. Switching to the rollover display, you get the same benefit of being able to relate two disparate attributes together, but from a different perspective. Other people prefer to compare different attributes this way, as I'm doing here. But when interpreting attributes, I prefer the attribute morph. It's just a matter of personal taste. Finally, we have two ways of combining different attributes together on the same display. The first of these is called multi-attribute, and what it does is drape the color and lighting from the background attribute over the structure and lighting of the foreground attribute. In this case, I will drape the instantaneous frequency over the instantaneous amplitude, because these two are often used together in the search for gas shadows. Here, I am draping the same instantaneous frequency over the original seismic. So again, this is yet another way of restoring the original seismic context to the derived attribute. Our last dynamic display, the multi-surface display, again has its origins in the depths of time. In this case, it descends from a 2005 CSEG convention talk that I gave called Enhancing Fault Visibility. I have included both the abstract and the presentation as lesson downloads. In the talk, I introduced the idea of using bump mapping to stamp coherence onto an image. You can see the effect here. The multi-surface display is its direct descendant, and I use it all the time whenever I have either similarity, coherence, or some other fault attribute available. What it does is combine the reflectance from the background attribute, in this case the similarity, with the normal display from the foreground attribute, in this case the seismic. You can use it on either vertical or time slices, and it's exceptional for highlighting faults and other discontinuities on top of the seismic amplitudes. So, This has been a very brief overview of what is an extensive series of functionalities. I have not gone into much detail. We'll fill that in as we go along. Right now, before you move on, I suggest you take a few minutes and just experiment with different combinations to see the effects. You will be glad you did.